And today on the bench is a phono preamp from high-end audio designer Tom Evans. It's the Mastergroove preamp. It's very expensive and I've been told I won't be able to fix it. And here it is, the rather modestly named Mastergroove. Somewhat simple around the back, phono input and output. But we have got 24 mystery dip switches on the back. I'll have to see what that's about later on. I'm not entirely sure when this was made, but I think this dodgy logo dated a bit. Ripping off the Intel Inside logos. There's a bit of a backstory to this. This preamp's not very lucky, let's be honest. It started off with a fault on one channel, buzzing, but then to add to its woes, the postman smashed it up. It looks very much like it's been bashed on this corner and it's smashed all this lid. And it's not little either. Look how thick it is. 10mm thick perspex or something. It also fails the rattle test. There's things rolling around inside. That's not encouraging. Let's check this out online, and this is from Tom Evans Audio Design, and it's a Mastergroove SR Mark III. Only 10 of these are made each year. Wow. This is basically a phono preamp, but it's for moving coil cartridges which have very low outputs. This is real high-end audiophile territory. It goes on to say, such is the overwhelming complexity and workload of hand measuring that perfectly matching every component of this ultimate phono stage, this limited edition model is only available at a rate of 10 units per year, featuring a custom case with fully balanced XLR output circuit as well as single-ended RCA phono output. Not this one. There's a lot of audiophile bragging rights going on here. Far more complex front end, 50% less signal distortion than the already referenced Mastergroove model. I'm not familiar with it, I have to say. This provides the greatest dynamic range of any phono stage in the world by an incredible margin. The new Mastergroove SR Mark III is quite literally beyond reality. And so is the price. Look at that. Well, who is this guy? Well, there he is. The genius himself, hard at work. Okay. Well, I do like the look of some of this equipment, especially this. Oh, and this. They're not very rare. I can't knock his taste in test equipment, that's one thing. Before I can test it, I've got to connect it to its power supply, which is rather large. My first impressions that this is somewhat overkill. It feels like there's a very big transformer in there for just powering a preamp up. So I'll just push this connector in there. I don't think it needs screwing in very much. Let's connect the oscilloscope to the output. See what's going on. Well, there's some funny stuff going on. I mean, it appears to have lost one of the traces. Oh dear, what is going on there? That is some big ripple. He's not kidding when they said buzzing. It's this channel. It seems to have settled a bit. Let's say we got 2, 4, 6, 8 milliseconds between each one of those little peaks. That's about 125 Hertz. That's not mains hum, that's something else. Might as well disconnect all these now. So we need to have a look inside. However, its sleek black exterior has no screws. They must be on the bottom. Little ID label on the bottom, serial number 58. Must be quite an early one. Well, you know, in the 6th year. Rather optimistically, it's got lots of digits. This could keep him going for 100,000 years. Well, there's plenty of screws on the bottom, but none of them look like they get the lid off. Well, maybe I won't be able to fix it, I can't even get in it. Although I do wonder what these are hiding, because this looks like it's half off. I'm a bit worried about peeling it off a £20,000 piece of kit. Oh, there we go. There's a nut. Might as well peel them all off then. Just going to go with the 8mm socket. Well, the foot comes off. I assume this pushes up. I hope the bottom doesn't come off and leave the top on. Oh, look at this. Oh, there's more braking parts here. That's not good either. Oh, bit of machine feature. Oh, crikey, look how bent that is. Oh, it's spinning round. Oh. And the last one. There we go. We'll carefully flip this over. Let's have a look what's inside. There's quite a lot of stuff in here for a phono preamp, and the Royal Mail, they really have done a number on this, haven't they? Crikey. That's been booted across the car park, I reckon. These sides feel like they just lift out, and they do. Oh. We got bits of cardboard and broken plastic in here. Oh. Oh no, these are the plastic standoffs that are supposed to hold this all together. Parcel courier's got some explaining to do, haven't they? I think this big bulky post can come out, and the front can probably come out. Oh, it's got a wire on it. Okay, we'll lay it down. Well, reminiscent of a pair of multi-storey car park blocks, there's a fair bit of duplication here. These four boards look identical, and they look for all the world to be power supplies. We got the L7815 CV3 voltage regulator. Pretty common, nothing special about that. Oh, but hang on, what's this? That's not fair. Look, they've ground the numbers off. I hope he's not done that all over it. Oh, but he has. Look here. Oh dear, all these transistors. Or whatever they are. But again, we're seeing the set of four. Grinding the part numbers off is very old school, but it's still plain dirty. There's still not many clues what these things do, apart from there's only a couple of wires on, and I just wonder if it's more power supply stuff. There's a lot of copper shielding on here. I think these are just blank PCBs. It's quite a cheap way to do it. Quite smart, really. All got a ground wire soldered to them. Presumably they all go to the same ground, like a star ground. Let's have a look. There's various things going on in here. There's a lot of silicon with the part numbers hidden. He really doesn't want us to know what they are. We'll see if this one's the same. I have a suspicion it's exactly the same. It's interesting that this is a double-sided board and this is single-sided. Has that homemade feel to it. But yes, I think these two boards are identical, which leads me to conclude that all four are the same. I think this is only held on by the one screw. That's all that's left holding this. Yes. Oh, hang on, that's revealed another one of these boards. What are they doing with them? We do now at least see a different board, this one here, which appears to have more chips with the part numbers ground off, but I'm going to guess they're op amps. I mean, it's a preamp. It must have them in. Oh, there's another one underneath. That's rather interesting. And I guess there's more of the same underneath. Yeah, it looks that way. I'm getting the impression this is built on two layers. Probably left and right. Or right and left, I haven't looked. Yeah, both these phono sockets go to this top board, which is the right channel. Okay, right on the top, left on the bottom. I shall check which channel was buzzing again, just to make sure. Sneak the power cable back in. There we are. Pull this one out, left channel, that's the one. Yeah, it's making no difference on the right. Let's measure the input voltage, red wire, 10.3 volts, white wire, minus 27. What's going on? Let's unplug this, see what's coming out of the socket. Let's put the negative in the centre, see what we've got. Minus 27, plus 27. Okay. So something's overloading the positive power supply rail and probably on the left channel. Trouble is, got to find it. Just a quick look at the wiring from here. The power comes into here, the plus and minus 28 volts I think it's supposed to be. These are all sort of joined together and they're distributed back to these boards. 1, 2, 3, 4. So H1, 2 and 3 are the inputs. So I'm pretty sure H7, 8 and 9 are the outputs. So this board here is supplying this blue board here, and these front boards are supplying these upper boards here. And you can see the same going on for the bottom part. And it looks like this op amp board's connected to this one somehow. And yeah, same going on underneath. Ah, right. Over here. Well, the power supplies are somewhat elaborate in this, and I'm not quite sure where it's all going, so I'm going to have to reverse engineer it, even if he has scraped all the part numbers off the things. But we can see in a £20,000 piece of kit there's a lot of labour going on here. I mean, if nothing else, the labour filing all these part numbers off must cost a fair bit. So I've now reverse engineered it and made myself a little service manual. I'm sure you'd like a look inside. Well, the first thing I managed to confirm was the layout. The top layer is the right channel, but the two are identical. The basic block diagram's pretty straightforward. The phono input goes directly into the low noise preamplifier, which is fed into an equaliser circuit, then through a low noise buffer and straight out the device. But in this design, they've done everything they can to keep noise right down to the minimum. The first thing to note is each active stage is powered by its own regulator. Each one of these are dual plus and minus 15 volt regulators. And these regulators are powered by their own regulators. How's that for thorough? And on the next page is the interconnection diagram, just showing how it's all wired together, pretty straightforward. Then we've got the power supply. There's nothing going to blow your socks off in here, pretty straightforward linear power supply with standard regulators. Moving on to the main board, which is the blue one, this is where all the action happens. And again you can see how the input signal goes directly into the preamp boards, two of them. Then they go for this little filter for equalisation, and then to this op amp here, which is the line output. And what's interesting here is they're loading each one of these op amps with its own constant current source. At least that's what I think it is. And on the next page we look at the low noise preamp board. And what we're seeing are 4 identical op amp circuits, and each one of these has got a gain of 605. Now, whilst a lot of audiophile stuff is complete nonsense, there is at least some science behind this. Here's a conventional op amp circuit. This is the non-inverting one, so the input goes to the positive input, and on the negative input we have 2 resistors creating a potential divider which creates the gain of the circuit. So you can put a small signal in and it comes out the other side amplified. But what happens if you put a tiny signal in? Like for this phono amplifier, we are talking 0.4 millivolts, which is certainly a tiny signal. But the op amp circuit will amplify it in the exact same way. Apart from this time, we're going to experience a load of noise on there. This noise is actually coming out of the op amp. The manufacturers will do whatever they can to minimise it, but it's very expensive to make low noise op amps, and there are ways to improve it. And the key behind this is the fact that noise tends to be random. So if we look at this clever solution here, we take our tiny signal again, but this time we put it through 2 identical amplifier circuits, each one introducing its own random noise. If we then join these outputs together, we create a summing amplifier, which doubles the amplitude of the output, but reduces the noise level, basically because the noise is random. So when you add 2 random things together, they tend to cancel out. The noise reduction is proportional to the number of op amps in parallel. So if you're going to use 8 op amps in parallel, you reduce the noise by 2.83 times. It's very important that each one of these op amp circuits gives the exact same output, which is why the feedback resistors are a very high tolerance. Look at that, 0.1%. If you're to look at the datasheet for an op amp, you'll see lots of information. A lot of it is a bit confusing, some of it's very useful, the pin out for example, but we'll get to the important bit I want to show you now, the electrical parameters. We scroll down enough and we'll see we've got the input offset voltage, and it's something like 5 or 6 millivolts. Now consider that with a signal with an amplitude of 0.4 millivolts amplitude. You'll get some weird distortion in that circuit. And we start to see the reason for the manufacturer's claims here about all this hard work measuring and matching every single